Okay, we're on chapter 12, and we started on section 12.2. I did skip section 12.1. I just didn't think it had a lot of importance. We could definitely hit some of the highlights of section 1 in section 2, and I thought it'd just be a waste of time. So we started with 2. So notice what the title is, surface area. Now we've talked about area. In fact, that whole last chapter, chapter 11, we talked a ton about area. But this is not just area of a flat surface, this is area of a prism and a cylinder. Let me show you an example of a prism. This would be a prism. Let's talk about it a little bit. Now I looked in the book and it said recall that a prism is, so we must have talked about prisms before. To tell you the truth, I don't even remember talking about prisms, but we'll start from right here. This is a prism. If you look at it, it's got a familiar shape from chapter 11. Look at the top of this and the bottom of it. They're exactly the same. So if the top and the bottom are exactly the same, we call those the bases of this prism. Now to be and this is a right, oops, I gotta change my writing here so I can see it. And there we go. So this is a right prism. And the reason it's a right prism, just like a right angle makes a 90-degree angle, see these edges right there? To the base, it makes a 90-degree angle. And same thing right here. It's a 90-degree angle to the top. So these are, I know you guys love to say straight up and down. That's kind of what you can think of right here. These sides are perfectly straight up and down with the bottom. They're perpendicular to the bases. So we call this a right prism. There is a thing called an oblique prism. If I took this thing and I kind of slanted it, I can't really do that with this picture. I just grabbed this picture from the internet. But if we slanted it, let's say the bottom still stayed flat, but this stayed flat on the top, but these edges kind of slanted off to the side, then it would be called an oblique prism. But we're going to stick with right prisms on this, at least in this lesson. So let's just talk about a right prism. It's a prism because the base and the two bases are exactly the same, and these sides just go straight up. If it's straight up, you got a flat surface on the top and the bottom, it's a prism. It doesn't come to a point. That's something else. That's another lesson. But on this one, it's flat on the top, flat on the bottom. It's exactly the same shape as well, okay? Because we call these the edges. These edges go straight up and down. All right, so that's basically what a prism is. We'll talk about cylinders after we talk about prisms. So this is a right prism. If we want to get real specific about it, how many sides does this prism, or does this base, this top have? It's 1, 2, 3, 4, 5, 6. So it's a hexagon. So we call this a hexagonal right prism. Sounds like a mouthful, but it kind of makes sense. Hexagon means the base is a hexagon. That's what the shape of it is. And it's right because the sides or the edges go straight up and down to the base. And it's a prism because of all the stuff we talked about as far as prisms. All right, so what we're going to do here is we're going to try to find the surface area of the prism. Now, I'm going to differ just a little bit from the book. The book loves to give you all these perfect formulas, and there's nothing wrong with it, okay? I'm not saying what they're doing is wrong. I just think there might be easier ways to figure out how to find the area of these things. They go through, I think they make it a little bit more complicated, but I kind of understand why they do it. Because you got to put in formulas and you got to say, okay, this is the formula for the area of a whatever. But I want to talk more generalities, okay, than specific formulas to this. What I'm going to do, if it says to find the surface area, is that a C? Yeah, it looks like it. Okay. If I wanted to find the surface area of this thing, what this means is I want to find the area of all the surfaces. So if I took this and I put it in my hand, flipped it around, turned it around, if you look at, and I like this picture from the internet too, because you can kind of see, see behind it, and you can see all the different sides. It's got this side right here. That's one side, 2. Then you got this one. Let's mark it. That's 1. This one right in front. This is 2, this one on the side. This one that's kind of covered up a little bit, we'll put a 3. That's that one right there. This one in the direct back, that would be 4. This one off to the side is 5. And this little one, it looks real skinny, but you know, it's because of the angle that you're viewing it, that would be 6. So you actually have 6 sides to this. So what we want to do is we want to find the surface area of all 6 sides. We call that the lateral surface area. And I will show you something for that. That's an E. Lateral surface area. Lateral means side. Okay, I used to play basketball, if you believe that or not, but I played a little bit of basketball, and we did this drill called the lateral drills for defense. You get down low and you go side to side, okay, side to side. That's a lateral. If you move laterally, people say, let's move laterally. That means side to side. So lateral means side. So it's the surface area of all the sides. So we call these the sides. There's 1, 2, 3, 4, 5, 6. Remember, you got a top and a bottom. What do we call those? We call those the bases. So a prism has two bases, the top and the bottom, and they're exactly the same. Those two bases are exactly the same. So if I find one base, what do? Just double it, and you got both the top and the bottom, or you can add them together. Now again, they go through this little bit of a drawn-out formula to figure that out, but I just like to visualize it and just see. If I wanted to find the lateral surface, I'm not going to memorize a bunch of formulas. What I'm going to do is say, okay, look, I got one side. If you look at this, this is a, I believe this is also a, I'm not sure if all of these, no, not all of these, but at least this one right here, I'm looking at the book, that's why I'm pausing here a little bit. I was thinking it was a, what do we call that? It's a regular prism, but it doesn't really have to be. In fact, let's just do this. Let's put some numbers in here. Let's put some values. I'm just going to make these up. Let's go blue on this, make it stand out a little bit. So let's say, you know what, I should just wait until they do an example. But they don't do an example with a hexagon one. I'm going to do it anyway. Let's just stick some numbers in here. Let's say it's regular. Okay, let's just pretend it's regular. So let's say this is, I don't know, I'll make it a little bit bigger than that. Let's make this bottom 8, and let's make the edge right here that goes from the top base to the bottom base. Let's make it, I don't know, 4. Okay, so let's make it 8 and 4, kind of easy. So if I wanted to find, and let's see, is there anything else I need to find? You know what? I'm making this too complicated. I'm just going off. I tell you what. Let's not do any numbers yet. Okay, let's play it safe. Let's not do any numbers just yet. Let's just stick with the examples they give us, so I don't really get ahead of myself. That's what I get for trying to go ahead. So if I wanted to find the area of this, what would I do? Well, I could find the area of one of these, and how many are there altogether? Well, there's 6 of them. So if I find one, I just take this area and multiply it by 6. Or you can do this. This is what they suggest that you do. If I want to find the area of all the lateral surface area, what we do is this. And I think this is a pretty good way, because we're going to use this quite a lot. Not just for this one particular thing, but we're going to use it for a lot of different things. We're going to find the perimeter of the base, and we're going to multiply it by what we call the height, or I've been calling it the edge right there. All right, so what are we finding? The lateral surface area. Sometimes I'll shorthand it LSA. I don't even think they do that in the book, but I just put that. The lateral surface area is the perimeter of the base times the height. Now, why is that? Because look, if I take this one right here, I would take remember the length times width, or base times height. So I would take this base and this height, multiply it together, I get 1. Then I would take the base times the same height, this base times the same height, this base times the same height, and keep on going around. Instead of doing that individually for all 6 of those, what I could do is I could just take this base, this one, this one, this one, this one, add them all up. Because it's the same height, then just take all those added up and multiply by the height. That's the perimeter of the base. So that's kind of a nice way of doing things. So the perimeter of the base times the height. That's the lateral surface area. We're going to do that a lot. So I'm going to put that in a box because I want to really remember that. The lateral surface area is the perimeter of the base. So I add up all the lengths, and they don't have to all be the same. Okay, that's what's interesting about this. It could be a weird looking hexagon. It doesn't have to be a regular hexagon. It could be a weird one, but as long as I add up all the lengths going around this thing, around this base, multiplied by the height, remember, because the height is the same on all of these. These lengths could be different around here, but the up and down part is going to be exactly the same. If it wasn't, it wouldn't be a prism. So we add up all the lengths of the sides, multiplied by the height, and that's the lateral surface area. Again, what if I wanted to find the total surface area, though? Okay, the total surface area. That's just the sides. That's all we've done so far. just find the area of all the sides. What do we have to do now? Well, we got to find the area of the top and the bottom. And so the total surface area would be what? The lateral surface area. Let's just write this down. It would be the lateral surface area plus 2 times the base. I think the book just used the letter L for lateral surface area. I kind of like LSA because it spells it out perfectly for you. Some people just like the shorthand version, I guess, just an L. But I'm going to write LSA. So the total surface area would be the lateral surface area, okay, plus the top and the bottom. You can memorize this if you want, but I want you to visualize it. I want you to see, how do I find the sides, all the sides? Well, you could do each one individually, okay, then add them all up, I guess. But a better way is just to find the perimeter of the base, multiply by how tall it is. That's the height. That would be from here all the way to here. That's the same all the way around. That's the lateral surface area. Then all I got to do is figure out what the top and the bottom is, and then add them together. That's the 2b, 2 times the base, twice the base. That's your total surface area. All right. Again, it's not like you have to memorize that formula. I'm not asking you to memorize this. Visualize it. Visualize finding all the sides, finding the top, finding the bottom, adding them all together right here. That gives you your total surface area. Now, with that in mind, let's actually do an example. All right, let's take a look at this one right here. This one is a little different than what we were doing. It's a triangle right here, but it's kind of sitting on the bottom. Is this thing a prism? It doesn't look like it because it looks like it comes to a point, but you got to picture it. Does it have the same top and bottom? Well, it doesn't look like it has a top. It's just like an edge on the top, and it looks like it's got this rectangular bottom down here. But if you think about it, if I took this thing, I'm not going to try to do this here, but if I took this and I flipped it up, then it could actually sit on this right here. So this could be the bottom. And then over here, you don't really see, it's not as see-through as that other picture was, but you can kind of picture it right here. See this part right here? That would be the top of it. Or you can sit it on this part, and this would be the top. So really, it does have 2 bases. It's got this as a base, and I'm not going to try to draw it because I don't know if I would be able to do it justice, but it would come down, I don't know, let's give it a shot. This is probably pretty bad. Is that right? I'm terrible at drawing 3-dimensional things. Oh my goodness, that's terrible. Let's get rid of all that mess. Okay. I think you can picture it though, can't you? You see this triangle over here as well. I wish I could take it and turn it around and all that, but I'm terrible at drawing 3-dimensional things. That's why I grab them from the web, and I don't have to draw them myself. Even with my nice little program, it's hard to do. Well, anyway, what are we going to try to do? We're trying to find the surface area. We want to find the total surface area of this whole entire thing. Now, there are times where you don't want to rely on the formulas, like that perimeter of the base times the height kind of thing. If you think about it, I'd have to find the perimeter of the base, so I'd have to find this side, and you've already got this to be 10, and then you can multiply it by 20, which would be the height. You could do it that way, all right? I'm not saying you can't, but it might be kind of a pain to figure out what that side is right there because they don't tell it to you, all right? So you're not really sure. You might be able to figure it out, but this is how I'm going to do it. I'll just show you this way. I want to consider all the different surfaces to this particular figure. Well, you got the 2 bases, so that's kind of easy. Let's just write it down. I'm going to list them all out, all right? So I just want to kind of do this not by formulas necessarily, but just by common sense. So let's look at the 2 bases. This would be a base, and then you got the same exact thing over here. So once I find one, I just double it, right? Because I got 2 of them, and then that's good enough. Now, what kind of a figure is this base? Well, it's a triangle. So what's the area of the triangle? It's 1/2 the base times the height. So it's 1/2. Now, when I talk base, I'm talking the base of this triangle, even though the triangle itself is a base to the pyramid, or the prism, not pyramid, sorry, that's another chapter. This is the base of the triangle, so it's going to be 1/2 the base of the triangle times the height of the triangle, just this triangle right here. What's the height of that triangle? That would be 15, all right? And then I can figure that out. So let's just find the one triangle. Well, that's 150 if I multiply that, and then half of 150 is 75. So this right here is 75. Well, you got another one back here too. Remember, it's a 3-dimensional object, and you can, like if you're going to paint it or you're going to paper it, wallpaper it or something like that. Okay, what surfaces are actually showing on the outside. Well, you got this triangle back here, so it's another 75. So I'm just going to add another, tell you what, let's do it underneath it here. I'm going to add another 75, and so now I get 150. I'm just going to put that in a box. That's not my answer. All that is the two bases. See? I've listed it right there. So the two bases, that's one with 75 and the back one's 75. Altogether, it's 150. All right, well, what other surfaces do I have? That's not so bad. Well, I've got this surface right here. Is that the only one of those I have? Nope. Over here on the other side, I have the same exact thing. So I'll just double that. I'll call it the two sides. Is that all right? I'll call it the two sides of this triangular prism. So what kind of shape is it? Well, oh, you know what? I still had to find this anyway, didn't I? How about that? So I'm still going to have to find that. I wasn't even thinking about that. I'm still going to have to find this length right here. So let's try to figure that out. I guess we have to make a little assumption here. We have to assume that this is probably a isosceles triangle. So let's do that. Let's make that assumption. It's an isosceles triangle. I hate to do that, but I probably should have told you that right off the bat. So if it is, then this whole thing is 10. Then this little bit right here is 5. And now I should be able to find this side right here. And how do we do that? We do it by Pythagorean Theorem. Okay, so we're going to use Pythagorean Theorem to find this edge right here. Let me put that in red just to kind of make it stand out a little bit. Make it a little thicker. There we go. So that's what I'm looking for right here. That's what I'm trying to find. Well, I've got a right triangle, so I'm going to go 5 squared plus 15 squared equals c squared. And let's see what we get. So I'm going to go 5 squared plus 15 squared equals, we'll just call it c squared. And then it's just Pythagorean Theorem. Let's use our calculator. Let's get a number for it. So I'm going to go 5 squared plus 15 squared equals 250. Take the square root of that answer right there, and that gives us about 15.8. So it's not much bigger than this, okay, because this is so small. This is so small in comparison. This isn't going to be a whole lot bigger. So it's almost 16, not quite. It's 15.8. So C is 15.8. What did we just find? We just found that little, this thick red line right there. So that would be, what, 15.8. Why did I care about that? Because I needed a length and a width to figure out this. This is a rectangle right here. That's one of the sides of this tent-looking thing, or A-frame building kind of looking thing. So I needed this 15.8 multiplied by the 20, and I've got this whole entire rectangle. So let's do that. Let's go 15.8 times 20, and that's going to give us just one side. Okay, we'll double it in a second, but I just want to do one thing at a time. So we're going to go 15. I should be able to do this in my head, but I'm going to do it on the calculator anyway. 15.8 times 20, and that gives us 316. So that's 316. What did I just find? I just found the area of this one side, but there's two sides. Remember, put that arrow over here? There's two sides of it. So if one side is 316, let's do that in red. So if this is 316, then this side over here has got to be 316. So we're going to add it right here, or you can just times it, multiply it, and what's that, 32, 632, I believe. All right, I'm going to put that in a little box. So what do I have so far? I've got the two bases. I got this triangle, and I got this triangle over here that you can't really see, but you know it's over there. It's on the outside. Then I've got this right side, and I have the left side. And so that's the 150 are the triangles, the two triangles, and then you have the 632, which is the two rectangular sides. We're almost done. I know it seems a little confusing right now, but we're almost finished. What other area do we have? Remember, I can take this and pick it up and move it all around. It's not just sitting on the ground where you can't see the bottom. You can actually pick this thing up, and you can actually see the bottom of it. And so that has a surface area as well. So what kind of shape is the bottom of this thing? Well, if you look at it, this is straight here, this is straight here. That would be a rectangle. And look at the two sides of the rectangle. This one's actually kind of easy. So one side of the rectangle is 10, the other side is 20. Because if you pick it up and you look at it, it's a rectangle on the bottom. And so we can figure out the area of that. So it's 10 and 20. So I'm just going to write bottom right here. See, we've got the two bases, the two triangles. We got the two sides, those are rectangles. And then we got the bottom, which is also a rectangle. And it's just the length times the width, or 10 times 20. And that is 200. And that's the third thing that I need to find. Now, how do I find the total surface area? I'll just put SA for surface area. I just add them up. All right, so let's do that. So it's just 150 plus 632 plus 200. And let's see what we get. That's a 2, that's an 8, that's a 7, that's a 982. So the total surface area of this would be 982 square whatever it is. Let's say it's in inches, okay? So let's say it's 982 square inches. So that's how you would find the area, the surface area of this whole entire thing. You've got the two bases. We can call it the front and the back if you want to call it that, whatever you want to call it. You got the two sides. These are rectangles. And the hard part about this was just figuring out what that side is right there. So you had to do Pythagorean Theorem to find that side. Then you can multiply these two together to get one side. You double it, and you get that's where you get your 632. All right, and then the bottom of it was pretty basic. That was pretty easy. Whoops, went a little too far. The bottom of it was a rectangle. One side is 10, the other is 20. Just multiply them together, you get 200, and then you just add them all up, and you get 982. That's the total surface area. So sometimes they can be a little bit confusing. Sometimes using just a straight up formula may be easier, may not be easier. I hate to go through this whole thing again, but if you wanted to, you could have done this. It might be a little easier. I'll tell you what, we might as well. You could have looked at it like this. You could have looked at it as, remember we said that lateral surface area thing? We said the lateral surface area is the perimeter of the base times the height. We could have made it a little easier on us. Let's see if it still works. The perimeter of the base. Remember, this is considered the base. So what would the perimeter be? Remember, this is 15.8, and this is 15.8, and the bottom of it is 10. So that would be, what's that? 1631.6. I hope my math is right on this. I'm doing a lot of this in my head. So it would be 31.6 plus the 10, which would be 41.6. So that's the perimeter of the base, 41.6. Remember, we're just trying to find the lateral surface area right now. Okay, so the lateral surface area is basically just the three rectangular sides. So hopefully it'll come out to what it's supposed to. Let's see if it does. I'm just flying by the seat of my pants on this one. All right, so the lateral surface area would be the perimeter of the base times the height. Now, what would the height of this thing? Remember, this is the base. Pretend that it's sitting on this. What would the height be? Well, the height would be this one right there, the 20. So we're going to multiply it by 20. Let's see what we get for that. Remember, this is just the lateral surface area. It's not our complete answer. So it's it'd be 20 times 41.6, and that gives you, did I hit enter? What just happened? Did my calculator go out on me? Oops, I don't know what happened. Let's try that again. That was weird. Never had that happen before. Times 20, and then that gives you 83.2. So 83.2 is the lateral surface area. And what do we have to do with that? We just have to add it to the two bases, right? So that should be, that didn't work. 41. No, there's no way. I put something wrong. Oh, I put 4.16. I was going to say. Should be like 832. Yep. So let's try it again. 41.6. Oh my goodness, I'm going crazy here. 41.6 times 20. And there we go. It's 832. I was wondering. There's no way it's going to be 83.2. Let's get rid of that decimal. There we go. That makes better sense. So it's 832 plus what? The two triangles. We already did the two triangles. Remember that was 150? So that's 150. You add them up, and that's an 8. That's a 9. Look at that. That looks familiar, doesn't it? That's 982, and it works out just the same. So that was actually not too bad. You still had to do some of that other work. You still had to do the work to get the 15.8. It probably all boils down to the same amount of work, but you can still see that you got the answer both ways. Whew, thank goodness it worked. All right, let's try another one, and we'll take a look at a cylinder. All right, here we go. Now we have a rectangular prism, because it's flat on the top and the bottom, and these sides just go straight up. So it's a prism, and the bottom is a rectangle. Let's use our little formula. Let's do the lateral surface area first. Let's do the lateral surface area. How do you do that? That's the perimeter of the base. I'll just shorthand it there. Put P of base, perimeter of the base, times the height. Well, what's our base? Well, it's actually sitting on the base right here. So from here, that part, it's a little squiggly. Let's make that a little bit nicer than that. So the base would be from here to here, if you can see that. It's kind of light. And then there to there. Okay? So that whole thing, that whole bottom right there would be considered the base. So we want to find the perimeter of the base. Now you should be able to do that pretty easy now. Because, you know, this side is 9. If it's a rectangular prism, that side right there is going to be 9. If this is 4, this one over here is going to be 4. So you should be able to figure out the perimeter pretty simple. So it's 9 and 9 is 18. And 8, it's, 26. So that would be, make sure I did that right. Yep, that would be 26. That's the perimeter of the base times the height. And the height is 6. And I should be able to do that in my head, but let's use a calculator instead. Sorry about that. It's 20. Let's turn it on. So it's 26 times 6. Oops, I can't do anything right today. 26 times 6, and that would be 156. So that would be the lateral surface area. What did we just find right there? Just by doing that simple little thing, we just found the lateral surface area, which means we found the area of all the sides. We're finding that, this back here, okay, and then this back here. Wow, that made a huge mess. But let's get rid of all that stuff. You just found all the sides. You found everything except for the top and the bottom. So now let's find the top and the bottom, or we'll call it our two bases. All right, if you take a look at the top and the bottom, we want to find the area of the top and the bottom. How do you find the area? Well, it's just base times height, or length times width. So it'd be 4 times 9. So it's 4 times 9, which is 36. That's the bottom of it. So that area would be 36, and the top would also be 36. So I'll add a 36. You could have just doubled it, put a times 2 here if you wanted to, and you would get, let's put it right here, you would get a 72. And so that's the lateral surface area. That's the two bases, the top and the bottom. And now you just add those two up. So it's 156 and 72. That's an 8, and that's a 22. So you should get 228. And it's surface area, so let's say it's in centimeters this time. So we'll go centimeters squared. And that's how you find the area of that whole entire thing. You could break it down into its parts, just find this rectangle, you know, and then this front one, this one over here, this one over here, the top and the bottom, add them all up. But it was a little easier just finding the perimeter of the base times the height. You can kind of do it almost in one shot. You don't have to do all 4 of those different sides. And then the top and the bottom, they're both exactly the same. So you just find one of them, you double it, you get 72, add them up, you get 228. Well, let's do a cylinder and we'll be done. Okay, here's a cylinder, and a cylinder is kind of like a prism. To tell you the truth, it's got a base. Now you can't kind of see it around, but you know that this kind of continues around in a circular shape. So the bottom is a circle, the top is a circle, and look at the edges or the height of it. We call this the height. That's it's perpendicular. It's straight up and down, if you want to call it that. Okay, it's perpendicular to the base. The height is perpendicular to the base. We've talked about that a bunch in the past. So how do I find the surface area of that whole entire thing? Well, watch. The lateral surface area formula that we learned is still exactly the same. It's the perimeter of the base. But look at the base this time. We don't call it a perimeter because our base now is a circle. What do we call the perimeter of a circle? Well, that would be the circumference. Okay, so it's the circumference. I'll write it all out. But it's still the same thing. This still boils down to the perimeter of the base times the height. But this just happens to be a circle. The base happens to be a circle. So I'm going to find the circumference, okay? That's the perimeter of the base, and then I'm going to multiply it by the height. The height is easy. They tell it to you. It's right here. It's 18. 18 goes from here to here. That's the height of this cylinder. Let's write that word down. Cylinder. All right? And they actually tell you the diameter of the cylinder. But in order to find the circumference, well, we can do it a couple ways. We can go 2 pi r, or you can just go pi d, couldn't you? So pi times the diameter, which is 15, and then multiply it by the height. How tall is it? It's 18, and then we can put that into our calculator. So let's go ahead and do that. So it's 15 times 18, and then you could put times if you wanted, or you can just hit pi. It's the same exact thing, and you get 848.2. So that's the lateral surface area, 848.2. We're not finished though. That's just this right here, okay, and all the way around. Okay, that's if you took a can and you sliced it right down the middle and you opened it up, you'd get a nice little rectangle right there. That area would be 848.2. So that's the lateral surface area. What do we still have to find? Remember, I can take this thing, pick it up. It's like a Coke can or Pepsi can. You can pick it up and you can move it all around. And so it's got all the sides, which you just found, but it also has a top and it has a bottom, the two bases. And I'm going to write that down. Right? It's the two bases. But what is the figure of this? It's a area, right? It's a circle, I'm sorry. So you're going to find the area of a circle. So how do you find the area of a circle? It's pi r squared. Now you're not going to put 15 in here because 15 is the diameter. What are you going to have to put in? The radius. So the radius of this would be half of 15, which is 7.5 or 7.5. So I'm going to put 7.5. Now that would be one of the bases. Okay, pi r squared, that's one. But the bottom, now remember, you kind of can visualize the bottom would be right here. There's two of them. There's the top and the bottom. So this is just one of them. If you wanted, just to make it a lot easier, just stick a 2 in front of it, and that'll give you both of them. You could find one and add them up, or you could just put the 2 in here and figure it out. And then once you do that, then we're basically finished. So let's do this. Let's go 2 pi, and let's go times 7.5 squared, and we get 353.4. 353.4. My memory's really bad. Let me make sure. Yep, that's right. Okay. 353.4. Now, what one is our answer? Is this our answer? Is that our answer? Combine. You got to add them up. Okay? You've got to add the two things together. So it's 848.2 and it's 353.4. And you're going to add them up. Let's see. Let me do this in our head, right? That's a 6, and that's an 11, that's a 9, that's a 10, that's a 9, that's a 12. So 1201.6. Let me just check, see if they got that. That's exactly what they have in the book, 1201.6. It's in millimeters, I think. So we're going to write it in millimeters squared. And that would be our answer. That's a 0 right there, by the way. Kind of ugly. 1201.6. And how did we do that? We found the lateral surface area by finding the perimeter of the base times the height. But the base of it is a circle. So the perimeter of the circle is the circumference. So it's pi times diameter. Multiplied by the height, 18, you get the 848 number. Then you had to find the top and the bottom. Those are our two bases. Notice what kind of figure the top is. It's a circle. So I have to find the area of a circle. So it's pi r squared. Why do I have the 2 there? Because pi r squared is just the top. We got to figure out the bottom as well. So I just multiply by 2, since both those circles are exactly the same. We get the 353 number. Add the 2 together. That's my lateral, my side. This is the top and the bottom together. Add them up, 1201.6, and you're finished. Sorry it took 30 minutes, but that's a lot of stuff to go through, and we'll definitely take some time in class to answer some questions on this. All right, and that's the kind of stuff we're doing in this chapter. All right, good luck with this. We'll see you next time.